Welcome back, everyone. I'm glad you're all still with us. I have to admit, I've been working in machine vision for many, many years, and it's only recently I've given much consideration to the computers being used. So we're very fortunate today to have Ken from Advantech with us, who can explain the merits of different bits and pieces of the computer system and perhaps how to optimize the system for your machine vision application. So without any further ado, I shall pass straight over to Ken.
Okay, good day, everybody. Nice to meet you. I am Kenny. I'm the Advantech product sales manager in charge of intelligent system products. And today, it's a great chance for me to introduce you my latest machine vision controller platform product, and also together with our value-added service and the comprehensive eco partnership. Okay, so before starting, let's have a glance on Advantech company profile. Advantech was founded in 1983, and the headquarters is in Taiwan. And with more than 35 years in the industry, our revenue reached 1.7 billion US dollars in 2019. The USA and China are the major markets, but however, the European has also been playing a significant role with 18% revenue share. And across all the countries in Europe, we have a local sales and technical support team to support our local key accounts and also the premium channel partners like OEM Automatic UK. And one thing worth to mention is that we have a brand new service center and warehouse in Eindhoven, Netherlands, and also another one RMS center in Warsaw, Poland, to offer the dedicated after-sales service to our European customers. And as you can see in the slide, Advantech's mission is to enable an intelligent planet, and we are continuously working with our local partners to offer the best industrial IoT solutions, which makes your application more intelligent and easier use. Okay, so first topic, let's talk about the challenges from the machine vision market to the machine vision SI. The machine vision technology is implemented in more and more various scenarios, such as the traceability of food and the pharmaceutical products, the inspection and measurement equipment for quality control, and something like the 3D vision for robot and autonomous guidance, and etc. And all the applications require different computing power, I/O interfaces, expansion slots, outlook, and form factor. So it's not easy to use just one computer platform to fulfill all the applications. And choosing a right machine vision control platform might be communicated to the machine vision SI. And then the second challenge, in the trend of Industrial 4.0, the factory is to focus on small batch, customized production. This means the factory production line will change frequently. And the machine vision system also needs to adapt to different objects quickly. And this could be a challenge for the rule-based inspection system because the SI needs to spend much time on modifying or developing new algorithms. And the third, in the high-end machine vision applications, such as big object, big area, or the fine small parts inspection in high speed, or something like a 3D vision for robot guidance. This kind of application require a high-end machine vision controller, which is capable of processing the high-resolution image data in very high speed. And to provide a price competitive machine vision solution to the high market could be a challenge to the machine vision SI. And finally, the edge system management. That means when a large amount of your machine vision system are deployed on the field, how to make yourself or your customer easily to manage the equipment in real time. This could be a big value to your customer, but it's not easy. It could be a challenge to the machine vision SI. So with the issues that just mentioned, we see the trends in the machine vision controllers. The first, the machine vision controller modularization. The second, heterogeneous computing for AI, 10 GB vision for high-end machine vision, and the cloud edge architecture implementation. Let's go through these items one by one. The first, machine vision controller modularization. In different applications, the machine vision controller is to be installed in different places. So you need to consider not only the dimension, but also cable routing, airflow, and etc. And also, depending on what and how many function blocks you want to integrate into the machine vision controller, you need to choose a right computer which has the right PCI or PCI Express expansion slot for you to install the ADAM card to realize the function of your machine vision system. And the fundamental parts of the computer, CPU, memory, hard drive, SSD, they need to be changeable to make your cost of machine vision controller optimized. So machine vision control modularization, that means the machine vision controller needs to be flexible, and you can easily customize the configuration to fulfill your application requirement. And that's why we see more and more customers who used to use Cognix or Matrix machine vision controller, they finally contact Advantech or our channel partner because we can offer the consulting service to the machine vision SI for them to choose the right platform for different machine vision applications. And then the second, heterogeneous computing for AI. When the factory changes its production line frequently, the machine vision system needs to adapt to different objects quickly. And this is a big challenge to the rule-based inspection system. And the machine learning technology, which use AI model to identify, to analyze, and classify the defect, is to help the machine vision SI to reduce their cost and effort on developing or rewriting the algorithms for different objects. And CPU with NVIDIA GPU card is the most prevailing combination for heterogeneous computing, for AI model training and inference. In this architecture, the CPU can focus on executing the code of OS and AP and transfer the workload of neural network and image processing to the GPU, which has thousands of this is why we see more and more requirements on installing the high-end GPU card in the machine vision controller. But GPU card integration is not just plugging the board into the chassis. Many factors such as heat dissipation, power supply wattage, cable routing, airflow, the mechanical design to well fix the GPU card in the chassis all need to be considered together. And this could be communicated to the machine vision SI, but this is our expertise. We have a wide range of product portfolio, and we are confident we can provide the right machine vision control platform for our customers. Here shows the product portfolio, which is ranging from small form factor, low power consumption product to the high-end, high performance scalable product. The iCam series are smart camera, which is the small form factor standalone machine vision system. The MIG AI series are the compact, fanless box PC designed with NVIDIA Jetson SoC, which integrate ARM processor and the GPU core, CUDA core, Tensor core for AI algorithms. And the ITS 3650G, it is another compact size fanless box PC, which supports the MXM GPU module. It's x86 architecture. And the MIG 700 IPC200i series are the modular IPC, which the user can add the I/O building blocks to extend the expansion slot or I/O interfaces up on your request. So it is very flexible. And the rack IPC, ACP, and HPC series are the high-end product which delivers the highest performance, maximum expandability for you to integrate all the function blocks into one IPC, and also support more than 10 cameras. For the ARM-based product, we offer the NVIDIA Jetpack SDK for you to develop your software on this platform. And these products are x86 based. They are designed with Intel CPU and chipset. So you can really add in the function blocks into the IPC using many existing drivers and APIs. And here we list the machine vision or the frame graver interfaces we offer on each platform. And here are the GPU cards, NVIDIA GPU cards supported by each product line. And the modular IPC, rack IPC can support up to high-end NVIDIA GPU cards for AI or image processing acceleration. And now let's have a glance on each product line. The first is smart camera. Why a smart camera is needed? The smart camera, comparing with the PC-based solution, it's an all-in-one solution, integrated all the hardware function blocks and also the machine vision software in the compact size enclosure. It's ready to use, ready for application product. Its size is very small, and it integrates everything. So the machine vision SI don't need to do complicated hardware assembly, cable routing, software porting. It's easy to be deployed to the field, and its reliability is higher. Because of low power consumption, the smart camera is fanless design, and it has no cable connections or the golden finger contact. That's why it's more reliable. And smart camera is suitable for 1 or 2 camera applications. It is not always the optimized solution for you to integrate a PC-based machine vision system and just attach to one camera. So the smart camera is for entry-level market, 1 or 2 camera for trace and track, OCR, OCV, or simple alignment. And the PC-based solution is suitable to be used with multiple cameras for high performance applications, such as inspection, measurement, or 3D robot guidance, and etc. And here is the smart camera product. On the left side, the iCam 7000 is x86 based product. It's designed with Intel Atom CPU and Cyclone product and the Cyclone FPGA. Sorry. And the Cyclone FPGA is the co-processor, which shares the image processing loading from CPU to make the whole system performance higher. And we offer Windows SDK. It supports the GenCam standard interface. So if you have existing machine vision software based on Windows, it would be easier for you to implement it on this new platform without too much coding effort. This makes you able to deliver the POC sample for a new project quickly. And here we can see the compact size of the smart camera compared with the pencil. They are very compact. And the iCam 500 series is our latest smart camera product. It is based on NVIDIA Jetson Nano NX SoC. It's ARM-based product integrated with GPU core for AI algorithms. For iCam 500, we offer the Jetpack SDK for you to easily develop the software on this new platform. The iCam 5000 also integrates the lighting, so you can see 8 LEDs here. It also integrates the lens, which supports autofocus. So you don't need to integrate the lighting source or lighting controller in your machine vision system just once. It's done. And you don't need to tune the focus for different objects. This makes your machine vision system very flexible. And here we show the modular machine vision platform, the MIG AI series, which is ARM-based, NVIDIA Jetson platform. MIG 700 series is Intel ATX86 architecture product. They are of modularized design. We have the I/O building blocks to be added to the machine vision controller. The I/door is a small module which offers I/O interfaces such as GBE, Wi-Fi, PIO, USB, serial port, and various kinds of field bus, CAN bus, Ethercat, Modbus, and etc. The I/door module is to be attached to the I/door slot. Like here is a small plate. Here is another small plate. So by I/door design, we can add functionalities to the machine vision controller, but it doesn't make the system size bigger. It doesn't occupy the expansion slot. And another I/O building block is the I/door, which offers PCI or PCI Express expansion slot. It attached to the MIG series like this one. And we also offer a wide range of frame engraver cards, I/O cards, communication cards, and even motion cards for you to integrate into the machine vision controller. Okay, here, let me share you one successful case, autonomous cleaning robot. This robot is used to clean the floor of the airport or the big shopping mall. And with the AI-based machine vision system, this robot is capable of drawing the map and charting the course by itself. It's automated, no human influence. And with the camera and the LiDAR, this robot can prevent collision with people or any object. So it's very safe. And it's also very efficient. It can clean 21,000 square feet floor per hour. The machine builder requires a compact size IPC with high performance CPU and support one high-end GPU card because it uses the AI model for navigation or image processing. And the IPC also needs to support 4 PoE cameras, and the LiDARs, 2 LiDARs are attached to the USB port on the front panel of the IPC, and the SSD is installed in the hard drive driver here. It's from accessible and easy maintenance. And this IPC is powered by the 24-volt DC electricity from the battery pack inside the robot. And the second successful case is AI heat-sink inspection. The end user is a factory of heat-sink. In the past, there are 10 people spending 30 seconds to inspect one piece of heat-sink, and the quality is hard to control, especially when people change. So the factory owner decides to implement the AOI system to inspect the heat-sink to ensure the quality. However, as you can see, this kind of, we call it the skyline fin, the skyline fin heat-sink. This kind of heat-sink, the tolerance of its size, the tolerance of its dimension, outlook, and also the thickness of the fins are big. The tolerance is big. So it's difficult to use a rule-based machine vision system to do the inspection. So the machine vision SI decided to implement the GPU computing power for AI model for inspection. And however, the environment inside this factory is not so good. It's a bit dusty, and sometimes they are flying metal powders in the air. So if we use a fan-based solution, the air inlet would be blocked by the dust, and the fan or the motherboard might be damaged by the dust or the flying metal powder. So we propose the MIC 730 AI, which is a high-performance ARM-based IPC based on NVIDIA Jetson Xavier SoC, which integrates CUDA core and Tensor core for AI model algorithms. And it's fanless, so it can operate stably in a dusty environment. And we use the I module that we just mentioned. It attached to the NIC, offers PCI fan extension slot for installing the frame engraver card. And the machine vision controller communicated to the robot controller by Ethernet interface. After implementing this inspection system, the efficiency increased a lot. The accuracy is more than 97%, and now only one people for final check is needed, and just 3 seconds needed to inspect one piece of the heat sink. Okay, and here we show the high performance machine vision platforms is x86 architecture. These systems are fan-based solutions and designed with Intel chipset and CPU. And with the fan in the system, the thermal condition is better, so we can implement high-end CPU such as Intel Xeon to increase the system performance. On the left side is IPC200 series. It's the ultra compact size IPC. You can see its size is very small. The depth is just 23 cm. And with its fan-based thermal solution, its cost is also lower than the fanless IPC, because fanless IPC needs a big heat sink for heat dissipation. And the cost of fan is lower than the big aluminum intrusion heat sink. And one point is that in some application scenarios of weak airflow or even no airflow, when you need to install a machine vision controller in this kind of environment, I suggest you to consider fan-based box IPC instead of fanless, because fanless IPC needs the natural airflow to take away the heat on the heat sink. If no airflow, then there is a high risk of thermal issue on the fanless IPC. But IPC200 series is a fan-based. It's suitable to be used in a no airflow environment. And on the right hand is the rack mount IPC, and we offer specially designed rack mount IPC dedicated for machine vision application. You can see the 4U chassis text is really short, and all the I/O, LED buttons, everything on the same side. This is for easy cable routing and easy maintenance. We have the high-end SKU, HPC 7420, which supports dual Xeon and dual high-end GPU card. And the IPC 631 is the mainstream SKU, which supports single Core I and single high-end GPU card. And here we share the successful case, the multiple angle AOI system for car chassis inspection. The car chassis is a big object with complicated internal architecture. So it's not easy to inspect it with fixed camera. So the machine vision SI designed the inspection system consisting 4 sets of 6-axis robotic arms, and the 12 cameras are attached to the robotic arms. And this inspection system uses the GPU card computing power for accelerating image processing. And this IPC also needs to be installed with 3 pieces of 4-port PoE frame grabber cards, and also 1 PCI slot is needed for the EIO cards for controlling the light bar, trigger the lighting, and etc. And the working space of this cell is limited. The SI uses a small 19-inch rack inside the working cell to install the IPC. So they require the IPC as short as possible. So we propose the IPC 631, the front I/O, or the I/O on the same side, easy cable routing, easy maintenance, with with short depth and with strong heat dissipation capability to support the highest CPU and the high-end GPU part. And this inspection system is very efficient. It can finish the inspection within just 80 seconds after getting the inspection request from the MES system. Okay, and this one is a vision guided robot for pick and place. It is a standard vision guided robotic architecture. It depicts the machine vision SI use the furnace IPC in the cabinet like this one, and the airflow inside it is weak. So it depends. This vision guided robot system is not stable because of thermal issue happen on the machine vision control. And you can see in the market, there are many computer vendors who offer complex size furnace IPC, but there are almost no computer vendor which offers fan-based complex size computer for machine vision application like IPC 200 series. Anyway, in the end, this SI come to Advantech channel partner, and we recommend them to use the fan-based IPC 200 series, the IPC 240, which offers 2 expansion PCI Express and the 2 PCI slot to install all the add-on cards needed. And it is suitable to be used in the airflow environment because it has this effect. So till now, the customer's inspection system is very stable, no thermal issue anymore. Okay, and then let's talk about another trend. There's 10 GBE vision for high-end machine vision. The entry or mainstream machine vision market is dominated by USB 3 or DD vision. Its market share may be around more than 50%. And for the high-end machine vision applications, they are occupied by Core Express and some by Camera Link. But Camera Link is a more legacy standard, and I believe for new projects, mostly they use the Core Express. The Core Express standard, the CXP 6, 10, and 12 are the most popular interface. And now we see a trend that the 10 GBE vision technology is replacing Core Express CXP 6 because the 10 GBE vision has higher bandwidth and longer cable. Also, the cost is lower than Core Express. If you do the comparison, you will find the camera, cable, frame graver card of 10 GBE vision are more economic than Core Express CXP 6. So we can see the camera vendors like Balmer, like Fuller, they launch their 10 GBE camera. And you can see many 3D camera vendors recommend the machine vision SI to use the 10 GBE interface to attach their 3D camera for the robot vision, for the autonomous navigation applications. And Advantech offer a wide range of frame graver cards, and the PCIe 1181, 1182 are the 10 GBE frame graver cards. We support up to 2 GB, 10 GB ports, and we use Intel 550 NIC chip, and we have a special design. You can see here. Here is the pin header. It is for 12-volt electricity output, maximum 2 amp. What is this for? It can be used to power the camera, lighting controller, lighting source, or something like the machine vision systems fan, and etc. This design is to save machine vision SI the cost and the space of 12-volt transformer. And you can see the 10 GBE frame graphic card is low profile form factor. That means it can be installed into the 2U rack mount server without the riser card. And all Advantech PoE cards support remote PoE power on-off. What is this? We offer software API for your software to turn off and turn on the power of PoE. When the PoE camera is freezed and not responding, your engineer don't need to go to on-site to reboot the camera. You just use software to reboot the freeze the camera to resume its function. It is very convenient. Okay, and the final topic, the trend cloud edge architecture implementation. As I just mentioned, when a large amount of your system are deployed on the field, easy management of the equipment could be a big value to your customer, but it could be a big challenge to you. Let's take the example of AI-based machine vision system. The machine vision controller is here. It do the inspection and generate the test result. And the defect part picture is stored in the machine vision controller on the edge. And the defect part picture can be uploaded to the cloud for retrain the AI model to increase the inspection accuracy. And the retrained model needs to be deployed back to the machine vision controller on the edge. And the cloud can be divided into two categories. The off-premise is the off-premise cloud is the public cloud, like Microsoft Azure, Amazon AWS. And the on-premise cloud is the private server in the enterprise or in the factory. If you decide to implement the cloud edge management architecture, we suggest you to start from the public cloud, the off-premise solution, because it is more cost-effective. After your architecture, your system is more mature and more data is generated, then you invest to build up your own private cloud to secure your data in your private servers. And however, to building up this architecture is not an easy task. For example, you need to consider how to optimize the data transfer between cloud and edge, because it is related to the telecom fee. It is related to the communication cost. And also another important topic is data security. So it will not be an easy task. And from Advantech side, we offer you a comprehensive eco partnership. We have a good relationship with NVIDIA, Intel, Seagate, and we develop our hardware solutions based on these big hardware vendors' products. And we can get the best technical support and the first-hand technology information from these vendors. And we have many ISV partners which can offer the AI solution for your machine vision products. And besides ISV, we also have our best partner in UK, OEM Automatic, who is a value-added distribution, who can distribute our hardware platform together with the key parts software of the machine vision product. And we also work with the domain-focused system integrator who can help you and your end customer to build up the cloud edge architecture. The business model would be like this. Advantech coordinate the ISV and together with OEM Automatic to develop the comprehensive hardware solution to the domain-focused SI. And the domain-focused SI can help you and your customer to implement, to build up the cloud edge solution with their domain-focused expertise. So if you are interested in this working model, please contact OEM Automatic, and we will invite the right partner to discuss your demand to build up your cloud edge architecture. Okay, so that's all of my presentation today. Do you have any question or comment? Just advice. Thank you.